Good morning. I am Dr. István Szintai. Let me show you the world in my eyes. I was graduated in medical sciences, so besides biophysics, I had a high school knowledge in the global temperature topic before I started to think about it. This makes me the opportunity to start from only general knowledges and an opportunity to you to follow me. I think my train of thought worth not to keep it in a secret, and this is the way I can express myself. My goal is simply the understanding itself. In this video series, I will collect the relevant information. I will search for relations between the available data that can be reached through the internet from a public interface, and I will show you a theoretical approach that you cannot find at any other source, and I will raise questions. The first data on this topic is the global average surface air temperature. The European Centre for Medium-Range Weather Forecasts, ERA5 reanalysis, uses a method that divides the surface of Earth into 0.25 degrees squares and count the temperature for each square. Hourly data has been available since 1940. 24-hour global averages are available at the website of the Institute, as you can see on the plot. This means that every temperature you can download daily is made by averaging 50 million at a number. The first thing that shocks those eyes who have never seen this plot before, that in the first half of the year, the average global temperature rises around 4 degrees of Celsius. Second half of the year, the temperature decreases 4 degrees. And this happens in every year with no exceptions. If we make a 4-year chart from the downloaded data, we can see that there is a systematic increase between the 1940s and the 2020s. Every date is elevated about 1 degree approximately. However, the shape of the curve is reminiscent of the sharpened sinus curve. Before talking about the systematic increase, I think we should understand why the average temperature increases and decreases 4 degrees in every year. The Climate Variability and Change Wikipedia site names 11 climate oscillations. However, none of these explain this phenomenon, and the climate pulse plot is not even displayed on the site. I was unable to find an explanation to the phenomenon which convinced me at other sources. Therefore, my first question is, why does the average global temperature decreases 4 degrees in every year from July till January? If anybody knows this, please do not hesitate to share the information. In this video series, I'm exploring my own thoughts about this phenomenon. At first, this decrease is almost the same in the 84 observed years. Relying upon this observation, I suppose that the yearly cyclic increase and decrease is independent from human factors and therefore may be based on larger factors than life itself. There are two main circumstances of Earth that cause cyclically change in some parameters over a year. The first is the elliptical orbit of Earth. This causes day-by-day changes in Earth-Sun distance and orbital speed. The second is the axial tilt of the Earth, which is responsible for the seasons. This causes day-by-day changes in the geographical latitude of the subsolar point. The subsolar point is a virtual point on the surface when the sun is in the middle of the sky, or in other words, when the sun is directly above our head, or in other words, when the incident angle of the sunlight is 0, or in other words, this is the closest point to the sun if we think Earth is a perfect sphere. In astrometry, they use the viewing angle of the sun at noon on the equator. It's called declination of the sun. Can we distinguish which of the two circumstances has a main influence on the global average temperature? With an online public application configured by the NASA, we can download the Earth-Sun distance and the declination parameters daily. On the next diagram, we can see the days of 1940. Each dot is 1 day. Within a period of a few hundred years, a noticeable difference would not be seen. Therefore, these dots are the same to human eye in 2020. On the x-axis is the Earth-Sun distance, measured in astronomical units. On y-axis is the latitude of the subsolar point, or declination. I marked the nodal points that are relevant to make the decision. The first one is the winter solstice, when the subsolar point is over the Tropic of Capricorn. It's around December 22 or 21st. The perihelion, when Earth is closest to the Sun. It's around 4th of January. The summer solstice, when the subsolar point is over the Tropic of Cancer. It's around June 22. And the aphelion, when the Earth is furthest from the Sun. It's 4th of July. These nodal points divide the year in 4 periods, 2 long and 2 short periods. While the long period, the Earth-Sun distance and the declination change almost synchronic. From perihelion, January, to the summer solstice, it's in June, increase as does the global temperature. From aphelion to the winter solstice, both decrease as does the global temperature. In the short period, the Earth-Sun distance and declination change opposite way. Is the approximately 2 weeks of time enough for the work of the opposite effect? If it is, then how does the global temperature changes between winter solstice and perihelion and between summer solstice and aphelion? Do the temperature change in direction during the short periods as same as in the long period before or as in the long period after? If the temperature changes in the short period as the long period before, then the change in Earth-Sun distance is the determinant effect. And vice versa, if the temperature changes in the short period as in the long period after, then the change in declination is the determinant effect. Fortunately, 2 weeks seems to be enough time to make a change. As you can see on the diagram, between winter solstice and perihelion, the values are mostly above zero, so winter solstice is warmer than perihelion. So the average global temperature mostly decreases during this short period. Between summer solstice and aphelion, the values are mostly below zero, so summer solstice is colder than aphelion, so the average global temperature is mostly increases during this short period. The average global temperature changes in the short periods as in the long periods before, so change in Earth-Sun distance is the determinant effect on change in average global temperature. Here we are entering into an embarrassing problem. If we make a big campfire, it is a common observation that close to the fire it is warmer than far from it. So without any other information, the expectation is that close to the Sun, Earth should be warmer than far from the Sun. The observations show completely the opposite. The average global temperature is low when Earth is close to the Sun and high when Earth is far from the Sun. And now we can suppose that mainly the change in Earth-Sun distance is responsible for the change in temperature. How could this be? More embarrassing thing that it exists a quite simple formula to describe the average global temperature with only one variable, which function results remarkably close values to the measurements. Additionally, as you will see, this function works fairly good until the 80s. But the most embarrassing thing is that I would fail on the admission exam to the Faculty of Physics because of the deduction of this formula, and I would agree with the professors upon the available literature. Honestly, I never tried to be a physicist, so please do not believe me. But consider my thoughts, try to answer my questions, and convince me. My first question was, why does the average global temperature decreases 4 degrees between July and January in every year? I think that some kind of balance is set at any time between Earth and the radiation of the Sun, and primarily the daily changes in the elliptical parameters of the Earth cause the cyclical change in the average global air temperature. I invite you to a guided collective thinking within my video series. In the next episode, we will start from the basics of physical laws. Please subscribe if you want more news. Be well, and don't forget the sun will rise tomorrow morning for sure.